It's marked as hard, but it's a good one. It has n workers, and we are given two integer arrays, quality and wage. What they mean is, quality is the quality of the ith worker, and the wage is the minimum wage expectation of that ith worker. For example, let's take you. You as an employee will have a quality. Okay, you know JavaScript, let's say other web technologies, I don't know, like let's say Node.js, React, Express, you know all that stuff. Let's say you know Android, you know machine learning also, and you know computer programming also. These are your qualities. And on the basis of these qualities, you will just expect, okay, this is my expectation of the wage which I should be getting. Now, a company needs to hire, same way, let's say take any company, needs to hire exactly K workers. They have a demand of exactly K workers they want to hire. But they will have these conditions because they know the employees can talk with each other, right? So they know that every worker in the paid group, again, the paid group is the group which they are hiring. They are doing a mass hiring, let's say, and they want to hire K workers. So the paid group, the K group which they're hiring, they must be paid at least their minimum wage expectation. So if you have expectation, let's say 15 lakh per annum, so you should be getting at least 15 lakh or more. So the amount which you are paid should be more than or equal to your wage expectation, right? Okay, and then each worker in the group pay, the pay which we are giving to a worker, that must be directly proportional to their quality, which means that the pay which I am giving them, it should be directly proportional to their quality. What it actually means, it means that a person having a better quality than you should be getting the exact same proportional amount than you. Let's say if you are getting 15 lakh per annum and you have, let's say, qualities X, but another person who having a quality as 2X, he should for sure be getting 30 lakh per annum. Thus, the company has to maintain this bar. So this is exactly what they are saying, that the pay should be directly proportional to the quality. And to just simplify this expression, what they actually mean, they said that this means if a worker quality is double that of another worker in the group, then he must be paid twice as much as the other worker. The same way I explained here also. So what we can infer from this, that if I am giving a pay of, let's say, 2x to him and X to him, which will directly say that his qualities are, let's say, Y and his qualities will be 2Y. So I can directly represent this entire thing as this particular equation, that pay of I upon pay of J will be equal to quality of I upon quality of J. You can also say as pay of I upon quality of I should be equal to pay of J quality of J. That also you can represent as. It is the same thing. So first condition is this one, that the pay of I should be more than the expectation. Expectation is the wage of I, which they have given the question itself. Now, ultimately your task is to give or spend, because you are the company, you are the Malik. You want to spend least amount of money needed. And again, as you can easily see, that you might have to give ratio, like you might have to give the pay in the proportion of some other employee. So your actual pay can become in a ratio, which means it can become a decimal number, right? Which means it can become, okay, the values can be having dot stuff. So please give in the precision of 10 raised to power -5. Now, one very basic thing is that you have n workers and you have to choose K workers. So for sure, when you will choose these K workers, and you know that you have to give as minimum pay as possible. So what you will do, okay, I will try to give, I know that I have to spend my money as much as possible. So everyone have their minimum expectations, and there will be someone who will agree to get minimum expectation, and according to that, I will pay him minimum. Whatsoever he required, I will pay him. And accordingly, maybe I can decide what I should pay others. For example, let's say I will try to pay him as much as possible. Whatsoever he demanded, whatsoever wage he demanded, I paid him that money. Again, whenever I say wage, I mean the expectation the person had, what is given in the question, and paid is what I paid to him. What paid is what I paid to him, and the quality is what the quality that person had. So I thought of, okay, let's take the typical corporate culture, that how at the year end, how we pay employees. We pay employees that, okay, we have a specific budget. We have a budget this much. we know that this employee will agree on that specific wage, and that is what their wage is. Wage is the minimum expectation. So give him minimum, give him exactly equal to what his wage demands, what his wage asks. And then accordingly, we know that how others' quality is in comparison to this person, then give others the same, in that same proportion. So we realize that first aim or first maqsad is that I will pay one of them equal to its wage, and I will pay others accordingly. When I say accordingly, I mean the proportion which we discussed in the point 2. And then I know I have to spend minimum money, so I will just try to make sure I will just give exactly equal to what I demand, exactly equal to the proportion which I demand. Now the one, as you see, that I will give one of them the minimum money or minimum wage, whatsoever he demanded, and give others proportionally. But how I will choose who will be the one who will get this as the minimum? Who will be that one? So I will try that minimum, I will try that person, everyone. Okay, I will try once he will be the minimum. As you can see, once he will be the one who will get minimum, next he will be the one, next he will be the one, next he will be the one. And whenever someone is the one who will get the minimum wage, others will get the wage, or others will get paid according to the qualities in comparison to this person. Cool. So the one at the current situation, the one who will get minimum wage, I will call that person as bechara. For the folks who don't know, it means poor fellow, because he is getting the minimum wage for sure. So he will be called as bechara. Now let's see what can happen. So I will take exact same example. This example I have taken, in which we have a person 1, Aryan. He has a quality of 10 and he expects the wage to be 70. The person 2, Akshay, he has a quality of 20, he expects the wage to be 50. A person 3, Aman, he has a quality of 5 and he expects the wage of 30. Now we know that we have to choose exactly two people. So far we have seen this condition. The condition is that the paid of I, whatsoever I am giving the person, should be exactly more than equal to my wage of I. What is his expectation? And also we have inferred this condition. Now if you remembered, I told you that I will have to fix one bechara. I'll have to fix one bechara. What I will do for that bechara? I know one thing for sure, that okay, I know this relation. I know I'm fixing the bechara. Let's say the bechara was the jth person. Bechara was, again, that will be just one bechara. At a time, that will be one bechara. So I fixed that one bechara, one poor fellow I have fixed. That is the jth person. So if I fix the jth person, I know the paid of j, because again, this is bechara, which means he will be getting the minimum. He will be getting the minimum wage. So this paid of j will exactly be equal to my wage of j. So wage of j I for sure know because I have fixed j. Quality of j I for sure know because I have fixed j. Quality of I for sure know because it is given in the problem. Then I can easily find how much I have to pay my I. And so I realized that if I fix my bechara, so I will get this fixed ratio, and that's how I can simply find how much I have to pay others. Others are I. I is everyone else except my j. So I know the quality of I will multiply by the ratio and I will get the pay of I. Let's see a simple example. Simple example simply says that Aryan, right now let's say he is bechara, which means he will get the exact minimum wage what he requires. So okay, he will get 50. But what will be the ratio of him? Ratio of him, again, it is a simple maths. The ratio of him will be wage of Aryan upon quality of Aryan. So wage of Aryan is 70, quality of Aryan is 10. So his ratio will become as 7. Now taking this ratio in consideration, I will have to find how much others I have to pay, which is paid of others. Others is I. So paid of Akshay will be ratio of bechara, which is Aryan, ratio, and the quality of Akshay. Quality is 70. So I should pay Akshay as 140. Okay. Same way I will take Aman, which is for sure ratio of bechara, which is Aryan, ratio of bechara multiplied by the quality of Aman, which is 5. I'll get 35. I remembered. I have fixed this, okay, no matter what, but I should take K. I should take K employees. I know that everyone, as you can see, 50 is more than 140. 50 was the expectation of Akshay, and now I am giving him 140. 30 was the expectation of Aman, I am giving him 35. So everyone is actually more than their expectation, and Aryan is also more than equal to. So I'm good to go. I should take 2 minimum out of them. So I will take 70 and 35. So in total, if I actually employ K employees, then I will have to give $105 to them. Now, same way, in this case, my Akshay will be now Bechara. Right? How I will say, okay, if Akshay is Bechara, which means I will give Akshay exact same amount, which is 50. Now, ratio will be 2.5, 50 upon 20, 2.5. See, this ratio is same way saying, if for 20 qualities, I am giving Akshay 50 wage, which means for one quality, I am giving Akshay 50 upon 20 wage. For 10 quality, I will give others as 50 upon 10, which is 25 wage. So you can see for 10, I will actually giving a 25 wage. It is a simple maths, but yeah, that's a ratio. It's just to represent how things are happening. Cool. So same way, I will get the wage of my Aryan, which is 2.5 into 10. And the same way I'll get the wage for Aman, which is 2.5 into 5. But the wage is 25, which is less than the expectation. Wage is 12.5, which is less than the expectation. So by this, I realized that I will have only one employee who is following the condition. So this configuration is not even possible, which means I cannot even take my Akshay as a Bechara. Okay, no worries. Let's try for Aman as Bechara, because that's the last person remaining to be as Bechara. So I will try Aman as Bechara. For sure, he will get exactly same as what his age is, what his wage is. Ratio will be 30.5, which is 6. Same way, 6 into 20, 120, 6 into 10, 60. Again, Aryan's expectation is more than the wage he's getting. So for sure, he's out. 50, 120. His 50 is less than 120. So Akshay is happy. In this case, my spend as a company, my spend will be 150. And I want to do a minimum spend. So I know that I will choose this 105 as the minimum spend. So I realized my minimum spend is 105. Now see what you did. What you did is you took one Bechara at a time. And for that one Bechara which you have took, firstly you took Akshay, then Aryan, then Aman. Then that one Bechara which you took, you found out the pay amount to other employees, and then you know that you have to take the K minimum employees out of them. Or you can say that one Bechara you will for sure take. Out of these, you will take K minus 1 minimum paid employees. Now, as soon as, again, so far, the things have not been much clear on what's the complexity and stuff. But still, K minimum, K maximum, as soon as this word comes in, your mind should click that maybe you can use a priority. I'm not saying that you will use, but your mind should click that maybe you can use. But still, we'll go on with the flow right now. Okay, we know that we will try for every Bechara. We know it will be O of n. We know that for every Bechara itself, I have to go and compute all the values and then ultimately get the K minimum. So for sure, it seems like I am going on to all the other person, which is roughly O of n also, and then maybe taking K minimum. But I know I have to only take K minimum. So why to even like do for all of them? Just simply keep on taking K minimum. So maybe I can take K minimum itself, which means I can maybe compute this K minimum only. Again, that's not sure, but maybe I can do it. Okay, so roughly by this case, it is very visible. It will be O of n square. Okay, can we improvise it? We have to improvise it. There's no option. We have to improvise it. Now, how to improvise it? Firstly, see what we were doing. We were taking one Bechara at a time, and for that one Bechara, we will finding out, okay, for others, what is the minimum pay I have to give. And again, for the other K minus 1 employees. Now, if I look at the condition very carefully, what I was doing, I just wrote exactly same stuff previously, right? If you remembered, this person I considered as a Bechara, which is the jth was a person was a Bechara, and then ultimately I was finding for others what's the value, and so on and so forth. If I club these two conditions, which means the condition, first condition, again, this condition was saying that condition number 2. But if I club both the conditions in this condition also, so if I know the paid of I will be quality of I multiplied by ratio of Bechara. Now, if I club it, which means paid of I should be more than equal to wage of I. So paid of I, it is more than equal to wage of I, which means my Paid of I is quality of I multiplied by ratio of bechara. Quality of I multiplied by ratio of bechara. It should be more than equal to my wage of I. Now again, just try to simplify it. Bring it in same terms as in ratio terms. So ratio will remain here, wage of I upon quality of I. Now, if you remembered, this ratio was the ratio of a jth person, which is the bechara person. So this ratio is the ratio of bechara. Ratio is the ratio of bechara. Ratio is the ratio of bechara. So this ratio is the ratio of bechara. And this wage upon quality is actually also the ratio, but it is for the ith person. So it is a ratio of ith person. So with combining these two conditions, we realized that the ratio of bechara person should for sure be more than equal to my ratio of I. Which means earlier, if you remembered, I was going on to all the people, but now that will not be required, because if someone is a bechara, then I know that I should only go on to the folks whose ratio is less than that of me, which is bechara. So what I will do, I will now find out the bechara value, ratio values of all the people, considering them as bechara. So okay, ratio for Aryan is 7, ratio of Akshay is 2.5, ratio of Aman is 6. So now I know that if anyone, again, if you remembered earlier, I was taking Akshay as a bechara, then I was going on to all the other values. But now I know if Akshay is the bechara and his ratio is 2.5, I should go on to only those ones who have the ratio value less than 2.5. But I see no one is having value less than 2.5. So maybe I am optimizing it. I am not going on to those values on which earlier I was going. So I did was, okay, I took these ratio values and I sorted them on the basis of these ratio values. So I sorted by the ratio values. So now this will become as sorted, in which I have the ratio value and then the person. Again, you can take the indexes of them also, or maybe anything which recognizes that this is corresponding to this specific worker or this specific employee. Now all these are sorted. So earlier, for the ith index, or for the any person as a bechara or the poor fellow, I was going on to all the other people. But now I know that for a specific poor fellow bechara, I will only go on to its previous one. I will not go on to its next ones. So technically it is improvised and complexity, but it is still O of n square, because for everyone, for every person, earlier you were going on to all the people. Now you are just going on to back people. So it is still O of n square, but still it is improvised runtime. But now your still aim is that how will you solve it? So maybe again, if you remembered on the previous, when I am saying that I will go on to the previous folks, what I will do, I will find their paid amount, how much I paid them, and so on and so forth. Let's imagine that my bechara was Aryan. Then I would have gone to all the previous values, find their paid value, and then I would have taken K. I would have taken, again, considering Aryan also, I would have taken K minimum paid values, because that is what I will be giving to my employees as a total sum. So I realized earlier I have n values. I have to choose K minimum values. So maybe I can use my priority queue in this, and rather than storing all the n employees previously in my sum data structure and then again doing a sort of finding K minimum, I can simply keep track of the K minimum paid values in my priority queue. Now K minimum paid values in my priority queue, and then maybe use those K minimum paid values. But again, if you remembered, the paid of anyone, paid of I is nothing but, if you remember, paid of I, if I show you paid of I, let's say this is the paid of I, again bechara will compute the ratio, I will be anyone else other than the bechara, he will be the ratio multiplied by the quality of I. So I know one thing for sure, the paid of I is quality of I multiplied by ratio. And again, this ratio is based on bechara, which is Aryan. So for sure, this ratio is nothing but wage of I upon quality of I, which is fixed by Aryan itself, because right now Aryan is bechara. Again, this is right now at this index, Aryan is bechara. And same way, paid of this specific Aman will be nothing but quality of Aman multiplied by ratio. Again, this ratio is based on the Aryan. Ratio is based on Aryan, but the quality is based on them. So we realized that at this specific ith index, I have to go on to all the previous indexes and find the k minimum. Now, for sure, rather than storing all of them in maybe a data structure and then doing a sort and then finding the smallest k, I can maybe take a heap and then store only the k minimum values. But still, even after going after, I will still have to go on to all the bicharas, which means all the people. For everyone, I am using a min heap, or maybe I'm using a priority queue. Don't go into min or max. I'm using a priority queue, which will store my k minimum paid. K minimum pays. So it will still be a k log k. Still, this is n into k log k. It is still more complexity. Now, how to improvise it? Before going on further, let's analyze what we did. So when ith person was a bechara, I firstly computed the ratio, right? And then what I did was I went on to all the previous elements and then computed their pay. So paid of 0 will be ratio into quantity. Again, this ratio is the ratio of the ith person, which is bechara. Pay of 1 will be ratio into quantity. Pay of 2 will be ratio into quantity. Pay of 3 will be ratio into quantity. Again, ratio into their quantity. Pay of 4 will be ratio to their quantity. Now, same way, if the I would have changed, so the one major thing would have been changed is ratio. Ratio would have changed because if the I changes, ratio changes, and thus all the previous value will also change. So that's an issue. If I change my I, everything else is changing. I want to restrict my change as much as possible. What I can infer from these two diagrams, I can infer very easily that what's happening. For I am computing the ratio, and this is the ratio. And after computing the ratio, what I will do? I will go and find the minimum k. Again, I'll go and find the minimum k paid values, because that will give me the minimum answer. So ultimately, after computing these paid values, I will go and find the minimum k paid values. Rather, if I imagine that, okay, these were the values I had, I was simply multiplying by ratio. Let's keep ratio out. And I know the ratio will be fixed for the ith index. So if I take minimum of k quantity values and then multiply by ratio, won't it be same? Yeah, it will be. So I realized I will take again. Why I am doing this? Because I know quantity is fixed. Even if my I is here, still the corresponding quantities will still be same. Ratio I will keep outside. So as to not multiply ratio at every point. It is for optimization we are doing. Now we realize we can just simply take the minimum k quantities and we will be good to go. So we realized what we are doing, and again, how it will help us for sure. We know that we will take minimum k quantities again, right? So let's say if this quantity was 2, this quantity was 4, this quantity was 6, this quantity was, let's say, 5. So I know I will take minimum k. K is, let's say, 2. I take minimum k quantities. I will take 2 and 4 minimum k quantities. Now again, let's say the next person comes. Okay, I go on to the next index. Again, I took the minimum key quantities. I will take their sum. I will maintain their sum in a variable. I'll maintain their sum, and then I will simply multiply by this ratio. Because I know I was at the ith index, which had a quantity of, let's say, 4. I know I was at the ith index. Again, consider this also. Let's take this also. Okay, this at the ith index. I know that this was the minimum quantity. I know the quantity sum is 6. Ratio I can very easily compute at the ith index, which is nothing but wage of I upon quantity of I, and then I'll simply find the minimum sum. Now, as my I shifts, I will encounter a new quantity. Now, if this quantity, again, let's say if this quantity was a 3, so I know that I have to take the minimum two quantities. So I will remove the maximum from my heap and then push minimum inside my heap. So now the minimum two quantities are 2 and 3. What I removed from the heap? I removed 4 from the heap. Earlier, my quantity sum was a 6. I removed 4 from the heap and I added a 3 in the heap. So this is my new sum, which is nothing but 2 plus 3, 5. So now my new quantity sum is 5, and for sure I'm at the ith index. I can simply get to know its ratio value, which is wage of I upon quantity of I, and I can simply multiply this quantity sum with this ratio, and I'll get the new current when ith is the bichara person. So you realized I was keeping track of the minimum quantities. Again, you saw that you have to remove what? Remove the maximum quantity. So removing maximum in a very small time, you need a max heap. That's the reason. You know that you can use a heap. You know that you can use a priority queue. But now you realize that you will need to remove the maximum quantity and then push in the current quantity. That is the reason you know that you will use a max heap. Okay, cool. Now the same way we did that, we will go and find the minimum k quantities. Again, we will maintain their sum in a variable so as to not find their sum again and again, and the ratio will be the current ratio of whichever person. Thus, I know I can simply use a priority queue. Now you see that what will happen exactly. This is what we want to implement. We'll go on to all the person I firstly before that we will have to sort them, because we know that we will only go on to the previous people. So we will only sort. Firstly, we will sort it. After sorting, we know that these are all sorted on the basis of their ratio. So first, make sure to sort on the basis of their ratio. When it is sorted on the basis of their ratio, now simply go on to the ith person. Again, when you are at the ith people, make sure you maintain the priority queue. Priority queue will be maintained on the basis of the quantity. I will simply push in the quantity in the priority queue, and I'll also maintain the sum of the current priority queue. Let's see the code. It's pretty simple. So it says that firstly, I will take my workers. Again, this is to sort all these workers. I will take the workers. Double is their corresponding ratio, because I know I have to sort the workers on the basis of their ratio. So I will firstly, I will go on to all the workers. As you can see, I go on to all the workers, and then I will just simply get the ratio. Ratio is wage upon the quantity. And also again, I can either push in the corresponding index of the worker, or why I have pushed in quantity, you will realize it later on. Why? Because you will see I only need the quantity as I go on in future. So that's the reason I have only pushed in the quantity. Although you can push in the index also, and later maybe from the index I can find the actual quantity. That's also very fine. Now when you have made this worker vector, simply sort it. It is the only reason you made this, because you have to sort on the basis of its ratio. So I will sort on the basis of its ratio. Now my aim is to get the minimum cost I will spend. So initialize my cost as my max. Again, this is double max, because I know it is not a long max or an int max, it is a double max, because I know everything will be in double. And then currently my quantity sum is 0. Again, remember this quantity sum is the heap, max heap sum. I'll make a max heap priority queue. I'll go on to all the workers. Again, this is the same way I'm going in the order of the workers. Same way. I will firstly get the current ratio. Again, you know the ratio is my worker dot first. This is worker dot second. So my worker dot first is the current ratio. I will firstly add, again in this quantity sum, I added the current workers contribution, and I pushed that also in my priority queue. Okay. The worker which I got, if I go up, if I go up as I land onto the ith worker, ith employee, I added this 3 in my quantity sum, and I added this 3 also in my priority queue. I added this 3 also in my priority queue. Right. Now I have to make sure if the priority queue size becomes more than k, I have to remove the maximum quantity element or quantity employee, a maximum quality employee. So I will simply firstly push the current, worker quality in my quality sum, and also push the current worker quality in my priority queue. But then I will check if the priority queue size has become more than k, remove the topmost, or basically the maximum quality person from my priority queue. And again, if you remove it, make sure to also subtract his contribution from the quantity sum variable, because that is maintaining the sum of my priority queue. Now ultimately check if the sum is equal to k, which means you have got the k employees, and try to minimize your answer. Answer is equal to minimum of answer and the quality sum. Again, this is quality, the quality sum multiplied by the ratio. If you remember, my answer will be nothing but the ratio. Again, this is the quality sum, whatsoever minimum k qualities I have, multiplied by the ratio. That will be my answer. So this will be quality sum multiplied by ratio, and that's gonna be how I will minimize my answer, by going on to all the workers. And thus my complexity will be again n log n for sorting, Going on to all the workers, O of n. For every worker, what I am doing is just pushing in the heap. So I can simply say it will be O of n log k. O of n log n for sorting and O of n log k for every worker. I'll push in the heap, pop from the heap, and heap size will remain at max k, because as soon as it exceeds k, I'm actually making sure I remove elements from the k. Elements removed from the heap if it exceeds k, and ultimately my space log n for sorting and k is the heap space, and that is our most optimal answer. Cool. I hope you guys got it. If yes, then please do share with your friends to actually expand more, because see, the reach is 0. I don't know why. People have complained a lot that even if they find the video, they cannot search it. Unless you will share it. If you like, again, if you like it, then only please do comment down below what you learned from the video, or you can just share with your friends. Bye bye. Take care.